Cuckoo. Informal definition, a mad person. Paradox definition. A seemingly absurd or contradictory statement or proposition which when investigated may prove to be well-founded or even true. This is CUCKOO paradox. Knowing the unknowable. We find ourselves as experiencing beings in a universe not of our making or design. However, upon further investigation, it would appear that the universe requires our observation for its very existence. It's the ultimate chicken and egg scenario. CUCKOO paradox will explore the scientific, metaphysical and other theories that sound cuckoo, but are they? The ultimate goal is to understand the world around us and our relationship to it. In the beginning, there was silence, peace, nothing. According to science, around 13.7 billion years ago, it happened, the Big Bang, where the first elementary particles burst into existence. In the intense heat and unimaginable speed, the universe was born, and inflation started. As time went by, the universe cooled and the first atoms were formed. See, science is based on a premise of the Big Bang, which is basically like saying, give me one free miracle and I'll explain the rest. The religious narrative is exactly the same. In the beginning there was the Logos, the Word. Let there be light. And there was light, and it was good. As a scientific species, mankind has discovered some counterintuitive aspects to our reality. These aspects have some interesting possibilities, which only now do we have the vocabulary to describe its implications. Are we real? Or are we living inside a simulation? This idea obviously sounds ridiculous, but as we delve into this subject, you will see how and why it's gaining ground in the mainstream science arena. After all, it is a CUCKOO paradox. The nature of light. Light is a curious phenomenon, as it can be described as a particle and as a wave. As we will see later, this is not unique to light. The speed at which light travels is 186,000 miles per second, and at these speeds, some very weird things happen. Time dilation describes the passage of time relative to the observer. First, we need some apparatus. Let's say a spacecraft, a light clock, and two observers. One will be inside the craft with the clock, and the other outside of the craft. Okay. The light clock comprises of two mirrors facing each other at a set distance, let's say 2 meters apart. A laser fires between the two mirrors and becomes captive, bouncing between the mirrors in a vertical beam. Currently, both observers have a stationary position relative to each other and the clock. The light ship then accelerates up to 167,400 miles per second, 90% the speed of light. From the perspective of the observer, let's call him Bob for now, on the light ship, the beam stays vertical. Both Bob and the laser are travelling at the same speed relative to each other. However, from the second observer, let's call him Tom for now, he sees something very different to Bob. The beam of the laser now follows a diagonal zigzag pattern across the sky and is no longer vertical. Now we know the distance between the two mirrors is fixed at 2 meters. Mirror A and mirror B. The diagonal path the light is taking from Tom's perspective is further than Bob's perspective. It's like having 3 mirrors. Mirror A, mirror B and mirror C. Mirror C is mirror A, but now it occupies a new position in space due to the incredible speed the craft is travelling. How can light give 2 different readings dependent on Bob's observations or Tom's observations? The answer is time has slowed for Bob, and from Tom's point of view, Bob would be moving much slower than he would normally. And from Bob's point of view, Tom would be moving much more quickly. However, Bob and Tom observe time passing as if it would normally do. At the speed of light, time stops dead. And it is this that intrigued me. You cannot accelerate matter to the speed of light, as the atoms would come apart and their bonds would break apart. The matter would get infinitely heavy and require an infinite supply of energy. Science has ruled out light speed travel. Light, however, can, as it has no mass. But this is where it's going to get a bit cuckoo. From light's point of view, there is no time, and if there is no time, there's also no distance, as speed is defined by time over distance. So at the speed of light there is no time, therefore no distance. So we need to think about light a little differently. Instead of thinking about waves or particles of light travelling through space, turn that around and say space-time reveals light at 186,000 miles per second, or every second that passes 186,000 miles of space is revealed. It's almost like all photons are in position in space-time for all of the probabilities, and it is our observation of those particles that give the illusion that they are moving. Simply put, photons on a DVD movie are captured in time and exist on the disc now. However, if we put that DVD in a DVD player, we can experience them over time and watch the 2-hour movie. Time dilation has to be taken into consideration for global positioning systems, as the clocks on the satellites tick ever so slightly slower than those on Earth and continually need adjusting to keep them in sync. If this was not understood, GPS would drift in accuracy by miles per day and would render the system useless. Interesting, don't you think? If you found this video interesting, please contemplate subscribing, leaving a comment or like. This channel will be updated frequently. You can find us at CUCKOOParadox.com and follow us on Twitter, Facebook and Google+. Our next video will be on the double slit and quantum erasure experiments, where we'll get a little bit more cuckoo.